In this video, we'll be solving the October-November 2023 question paper 33, that's Pure Maths 3, for the CIE A Level Maths 9709 exam board. Subscribe and let's get into it. Number 1. Find the set of values of x satisfying the inequality the modulus of 2 to the power x plus 1 minus 2 is less than 0.5, giving your answer to 3 significant figures. Okay, so we can write that inequality as 2 to the power x plus 1 minus 2 squared. So if we remove the modulus sign and square both sides, 0.5 to the power 2. To make our lives simpler, we'll use the substitution u is equal to 2 to the power x plus 1. So we're going to replace this 2 to the power x plus 1 with the u. So that becomes u minus 2 squared is less than 0.5 to the power 2, which is 0.25. Now we have a quadratic inequality. So let's solve our quadratic inequality. You can see that we have it in a sort of a completed square form. So we can solve using the completed square method. So we're going to take the square root of both sides, so that becomes u minus 2. I'll use an equal sign here. We'll get back to the less than sign later when we have our roots. So this is plus or minus the square root of 0.25. So u minus 2 is equal to, what is the square root of 0.25? That's half, I believe. So plus or minus 1 over 2. So u is equal to 2 plus or minus 1 over 2. So let's write that as two separate equations. So we've got 2 plus half. 2 plus half gives us 5 over 2. And we've got u is equal to 2 minus half. 2 minus half will give us 3 over 2. And now remember that we said u is equal to 2 to the power x plus 1. So we can now substitute u with 2 to the power x plus 1. So this becomes 2 to the power x plus 1 is equal to 5 over 2. And the same goes for this side. That's 2 to the power x plus 1 is equal to 3 over 2. And now we're just going to solve both equations using logarithms. So take the natural log of both sides. Ln 2 to the power x plus 1 is equal to ln 5 over 2. And now we're going to bring down the power. That's x plus 1. Ln 2 is equal to ln 5 over 2. And so this, if we expand our bracket, that's x ln 2 plus ln 2 is equal to ln 5 over 2. And now let's make x the subject of the formula. So that's ln 5 over 2 minus ln 2. So if we just combine this, x ln 2 is equal to ln 5 over 2 divided by 2 using laws of logarithm. So that's ln 5 over 4. And so x is equal to ln 5 over 4 divided by ln 2. Let's just check if we're asked to give this an exact form or not. Give your answer to 3 significant figures. Okay, so we can punch this into our calculator. That is ln 5 over 4 divided by ln 2. And that gives us 0.322, correct to 3 significant figures. Let's solve our other equation. So that becomes ln 2 to the power x plus 1 is equal to ln 3 over 2. We bring down the power. X plus 1 times ln 2 is equal to ln 3 over 2. Expand the brackets, so that's x times ln 2 plus 1 times ln 2, and this is equal to ln 3 over 2. And if we make x the subject of the formula, this becomes ln 3 over 2 minus ln 2 So x ln 2, let's combine the two logarithms. So that's ln 3 over 2 divided by 2. So that's ln 3 over 4. And now let's divide both sides by ln 2. So ln 3 over 4 over ln 2. And if we punch this into a calculator, that's ln 3 over 4 divided by ln 2. That gives us negative 0.415. Now remember that our solutions are coming from this quadratic inequality. So we're giving this as a set of values rather than just roots. So if we sketch our quadratic, that's u minus 2 squared, it would look something like this. This would be in this case, that would be u-axis. So we have our roots here. For u, we had 5 over 2 and 3 over 2. So this would be the smaller one, 3 over 2, and this is 5 over 2. So this means that this is the region that we want. But remember that we're giving our answers in terms of x. So instead of using the values for u, we use the values for x. X is between negative 0.415 and 0.322, and this would be our final answer. Number 2. On an Argand diagram, shade the region whose points represent complex numbers z satisfying the inequalities z minus 1 plus 2i is less than or equal to modulus of z, and modulus of z minus 2 is less than or equal to 1. Okay, so let's start by rewriting these inequalities. I want to factor out a negative sign here. So that becomes 1 minus 2i, and this is less than or equal to the modulus of z. And if we do the same for the other inequality, that z minus, this will be 2 plus 0i, and this is less than or equal to 1. So let's start by drawing our Cartesian plane. So this will be our imaginary axis, and then let's do our real axis. This is the real axis. Let's plot this point over here. That's 1 minus 2. So 1, let's say minus 2 is somewhere here. So our point is over here. And then z, when it's just z, it means that our point is the origin, O. So it means we have a line joining these 2 points, and we need to bisect that line. So here I do not have a compass with me, but you should use your compass to draw the construction arcs and bisect your line. So I'm just going to draw some imaginary construction arcs here, but use your compass to bisect the line, something like that. And then the line going through the points. That's our bisector. We want the region that is closer to 1 minus 2. So 1 minus 2 is this point over here, and we want the region that is closer to 1 minus 2, which would be this side of the bisector. Since they say it's less than or equal to, it means that it should be closer to 1 minus 2. So I'm just going to erase that so that we can draw our other inequality, and I'll draw it in, let's draw it in blue, in red in fact. So we've got our coordinates 2, 0. So this is 1, 2 would be somewhere here, 2, 0 is here. And we want to draw a circle with a radius of 1. Okay. And so our circle would look something like that. Forgive me, it's not very accurate, but I'm sure you get the idea. So that's our circle that's satisfying this inequality. And now we want the region that satisfies both inequalities. So this region must be within the circle, but it must also be closer to the point 2, 1, negative 2, which is that point. So it means that the region that we want is this region over here. It's within the circle and is closer to 2 to 1, negative 2. So the region that I shaded in gray represents our required region, and that's our final answer. Number 3, the polynomial 2x cubed plus ax squared plus bx plus c, where a and b are constants, is denoted by p of x. When p of x is divided by x plus 2, the remainder is negative 38. And when p of x is divided by 2x minus 1, the remainder is 19 over 2. Find the values of a and b. Okay, we're given that when p of x is divided by x plus 2, the remainder is negative 38. So using the remainder theorem, we can state that p of negative 2 is equal to our remainder, negative 38. And we are also given that when p of x is divided by 2x minus 1, the remainder is 19 over 2. So again, using the remainder theorem, we can say that p of, in this case, half is equal to 19 over 2. So the value that we put here basically represents the value you get for x when you equate the bracket to 0. So if you had x plus 2 is equal to 0, our x would be negative 2. If you had 2x minus 1 is equal to 0, our x would be half. Okay. So now we're going to use p of x to evaluate both sets of equations and therefore determine our values of a and b. 2 times negative 2 cubed plus a times negative 2 squared plus b times negative 2 plus 6 is equal to negative 38. So negative 2 cubed is negative 8 times 2, that's negative 16 plus 4a minus 2b plus 6 is equal to negative 38. So that's 4a minus 2b. Then we have 6 minus 16, which is negative 10, plus the 38 if we move this to the left-hand side. So this is all equal to 0. So 4a minus 2b, and that's plus 28 is equal to 0. Now let's evaluate our other equation over here. So substitute x with half. That's 2 times half cubed plus a times half squared plus b times half plus 6, and this is equal to 19 over 2. Okay, so half cubed is 1 over 8. 2 times 1 over 8 gives us 1 over 4 plus a quarter a plus 1 over 2b plus 6, and this is equal to 19 over 2. So this becomes a quarter a plus half b. Then we have 6 plus a quarter, 6 plus 1 over 4. That gives us 25 over 4. 25 over 4. Move the 19 over 2 to the left-hand side. So that's minus 19 over 2 is equal to 0. So that's a quarter a plus 1 over 2b plus 25 over 4 minus 19 over 2, which is negative 13 over 4. So that's negative 13 over 4 is equal to 0. Let's multiply through by 4 to get rid of the denominators. So that's 2b minus 13 is equal to 0. Now we have two equations in terms of a and b, and we can solve these two equations simultaneously. So let's make a the subject of the formula in our second equation. So a is equal to 13 minus 2b. So let's substitute into the first equation. That's 4 times a, which is 13 minus 2b, minus 2b plus 28 is equal to 0. So we've got 4 times 13, 4 times 13, that's 52. 52 minus 8b minus 2b plus 28 is equal to 0. So 52 plus 28, that gives us 80. So 80 minus 10b is equal to 0. 10b is equal to 80. Divide both sides by 10. B is equal to 8. Now let's substitute 13 minus 2 times b, which is 8. So that's a is equal to 13 minus 2 times 8 minus 3. A is minus 3. Therefore, our final answer is A is equal to -3 and B is equal to 8. Number 4. Solve the quadratic equation 3 plus I times w squared minus 2w plus 3 minus I is equal to 0, giving your answers in the form x plus iy, where x and y are real. So this is a quadratic equation, but it has imaginary roots, so that means that we're going to solve this using the quadratic formula. So w is equal to, in this case, this would be a, and this would be b, and this would be c. So minus b, which is 2, plus or minus the square root of b squared, so that's 2 squared, minus 4a, which is 3 plus I, c, which is 3 minus I, and this is O over 2 times a, so that's 2 times 3 plus I. So w is equal to 2 plus or minus the square root of 2 squared is 4 minus 4. Then 3 plus I times 3 minus I is a difference of 2 squares. So that's 9 minus I squared. And this is O over, let's not expand our denominator yet. It might prove useful in the future. So w is equal to 2 plus or minus the square root of 4 minus 4 times 9 minus I squared is minus 1, so that becomes minus minus 1, which is plus 1. And this is over 2 times 3 plus I. So w is equal to 2 plus or minus the square root of 4 minus 4 times 10, which is 40, and this is over 2 times 3 plus I. W is equal to 2 plus or minus the square root of 4 minus 40, that's minus 36, over 2 times 3 plus I, and we can write minus 36 as minus 1 times 36. So w is equal to 2 plus or minus the square root of minus 1 times 36, and this is over 2 times 3 plus I. Once we've written minus 36 as minus 1 times 36, this allows us to distribute the square root sign so that this becomes root minus 1 times root 36, and this is O over 2 times 3 plus I. And so w is equal to 2 plus or minus root negative 1. We know that I is equal to root negative 1. And then root 36 is equal to 6. So this becomes 2 plus or minus 6i. And this is O over 2 times 3 plus I. And now let's factor out a 2 in our numerator. So that becomes w is equal to 2, 1 plus or minus, that's 3i, and this is O over 2 times 3 plus I, and so the 2's will cancel out, and what you end up with is w is equal to 1 plus or minus 3i over 3 plus I. We're going to write them separately. So that's 1 plus 3i over 3 plus I. And then we have w is equal to 1 minus 3i over 3 plus I. And now we will do division. So we're going to multiply by the complex conjugate of our denominator. So that's 3 minus I. Divide that. That's 3 plus I. And then that's 3 minus I. So if we expand our numerator, we've got 3 minus I plus 9I. So 9I minus I, which is 8I. So we've got plus 8I. And then we have negative 3I squared, negative 3I squared. And on the denominator, we have a difference of 2 squares, which is 9 minus I squared. And this will simplify to give, we know that I squared is negative 1, so that will become 3 plus 8I minus 3 times negative 1 gives us positive 3. And this is over 9 minus I squared. I squared is negative 1. So 9 plus 1 on the denominator, which is 10. And this therefore simplifies to 9 plus 8I over 10, which goes on to give 9 over 10 plus 8 over 10I. And now let's evaluate 1 minus 3I over 3 plus I. So let's do this on the side. So that's 1 minus 3I, and we're going to multiply by the complex conjugate of our denominator, 3 plus I. So that becomes 3 minus I, and this is over 3 plus I times 3 minus I. So in the numerator, we get 3 minus I minus 9I, which is minus 10I. Then we've got plus 3I squared, and this is over, that's a difference of 2 squares, 9 minus I squared. So in our numerator, we've got 3 minus 10I plus 3 times negative 1. So that will be negative 3. And this is all over 9 minus I squared is negative 1, so that's 9 minus minus 1, which is 9 plus 1. That gives us 10. So what you end up with is negative 10I over 10, which is simply negative I. And so therefore, our final answers would be 9 over 10 plus 8 over 10I, and this negative I over here. Or you could write it as 0 minus I if you wanted to. Number 5, find the exact coordinates of the stationary points of the curve y equals e to the power 3x squared minus 1 over 1 minus x squared. Okay, so to do that, we first have to find dy dx, and we're going to use the quotient rule. So let's hold our denominator 1 minus x squared and differentiate our numerator. So if you differentiate e to the power 3x squared minus 1, we have to differentiate this part and bring it down. So that would be 6x, and that's e to the power 3x squared minus 1. So this becomes times 6x e to the power 3x squared minus 1. And that's minus, let's hold our numerator e to the power 3x squared minus 1 and differentiate our denominator 1 minus x squared, and we get negative 2x. And this is all over our denominator 1 minus x squared squared. So dy dx is equal to 1 minus x squared times 6x e to the power 3x squared minus 1 minus, or that becomes plus 2x e to the power 3x squared minus 1. And this is all over, that's 1 minus x squared squared. So we can factor out dy dx is equal to, we can factor out 2x e to the power 3x squared minus 1 over our denominator, which is 1 minus x squared squared, and then what remains is this bracket over here multiplied by 3 because we have 6. So it's 3 times 1 minus x squared here, and then we have plus 1 for that part. So plus 1. So dy dx is equal to 2x e to the power 3x squared minus 1 over 1 minus x squared, and that's if we expand 3 minus 3x squared plus 1, which further simplifies to give 2x e to the 3x squared minus 1, open brackets, 3 plus 1, that's 4, so it's 4 minus 3x squared, and this is all over 1 minus x squared, and this is dy dx. Since we want the coordinates of a stationary point, we can equate dy dx to 0. So this becomes 2x e 3x squared minus 1 times the 4 minus 3x squared, and that's 1 minus x squared. This is equal to 0. Let's equate the first bit to 0, so 2x e to the 3x squared minus 1 over 1 minus x squared is equal to 0, and then we have 4 minus 3x squared is equal to 0. Let's start by solving the first equation. So this will become 2x e to the 3x squared minus 1 is equal to 0. And then you've got 2x is equal to 0 here. And you've got e to the 3x squared minus 1 is equal to 0. What we've just done is we've basically put a bracket here. And we're saying each bracket is equal to 0. So in this case, x would be 0. And in that case, you have to take the natural log of both sides, and we know that ln 0 does not exist, so x is equal to no solutions. In fact, let's probably show that ln e to the 3x squared minus 1 is equal to ln 0, so x equals no solutions. No solutions. And then we come to this equation. We've got 3x squared is equal to 4. So x squared is equal to 4 over 3. Take the square root of both sides. X is equal to plus or minus the square root of 4 over 3. And we can simplify this to be x is equal to plus or minus the square root of 4 over the square root of 3. The square root of 4 is 2, so that will be 2 over root 3. And now we have to evaluate the y coordinates when x is 0 or when x is equal to plus or minus 2 over root 3. So let's start with when x is 0, y is equal to e to the power 3 times 0 squared minus 1, and this is all over 1 minus x squared. So this is over 1 minus 0 squared. So this will give us y is equal to e to the negative 1. So our first set of coordinates is 0, e to the negative 1. And now let's evaluate when x is 2 over root 3. So at x is equal to 2 over root 3, this would be y is equal to e to the power 3 times 2 over root 3 squared minus 1, and this is all over 1 minus 2 over root 3 squared. We get in our numerator, it becomes, you get e to the power 3 over minus 1 over 3. And so this becomes y is equal to negative 3e to the power 3. Now let's evaluate when x is equal to negative 2 over root 3. So that's y is equal to e to the power 3 times negative 2 over root 3 squared minus 1. 1 minus negative 2 over root 3 squared. And since x is squared in both instances, we'll get the same result of y is equal to negative 3 e to the power 3. So it means that our three solutions would be 0, e to the negative 1, and then we've got 2 over root 3 and negative 3e cubed. And then finally, we have our third solution, which is negative 2 over root 3 and negative 3e cubed, and this is our final answer. Number 6, part A. Show that the equation cos squared theta plus 2 cos 2 theta is equal to 4 can be written in the form 4 sine to the power 4 theta plus 3 sine squared theta minus 1 is equal to 0. Okay, so we're trying to get this equation to be a quadratic equation in sine squared theta. Okay, so let's start by writing cos squared theta in terms of tan squared theta. So that would be 1 over tan squared theta plus 2 cos 2 theta. Let's use the double angle formula for cos 2 theta, the one that has sine squared theta. So that's 1 minus 2 sine squared theta, and this is all equal to 4. Let's first expand this. 1 over tan squared theta plus 2 minus 4 sine squared theta. Let's bring the 4 to this side, so that's minus 4 is equal to 0. So we've got 1 over tan squared theta minus 4 sine squared theta minus 2 is equal to 0. We can write tan squared theta as sine squared theta over cos squared theta. So tan squared theta is identical to sine squared theta over cos squared theta. So this would become 1 over sine squared theta over cos squared theta minus 4 sine squared theta minus 2 is equal to 0. And if we resolve our fraction, that's cos squared theta over sine squared theta minus 4 sine squared theta minus 2 is equal to 0. Now let's multiply through by sine squared theta to get rid of this denominator. So that becomes cos squared theta minus 4 sine squared theta times sine squared theta, so that becomes sine to the 4 theta, minus 2 times sine squared theta, so that's minus 2 sine squared theta is equal to 0. And now let's use the identity. Cos squared theta is identical to 1 minus sine squared theta, to write this in terms of sine squared theta. So that's 1 minus sine squared theta minus 4 sine to the 4 theta minus 2 sine squared theta is equal to 0. And let's simplify like terms. We've got minus sine to the 4 theta minus 3 sine squared theta plus 1 is equal to 0. Let's multiply through by a negative 1, so that becomes 4 sine to the 4 theta plus 3 sine squared theta minus 1 is equal to 0. And this matches the equation we're supposed to show. 4 sine to the 4 theta plus 3 sine squared theta minus 1 is equal to 0. Let's move on to part B. Hence solve the equation cos squared theta plus 2 cos 2 theta is equal to 4 for theta is between 0 degrees and 360 degrees. So we've seen that equation we're required to solve can be reduced to 4 to the sine 4 theta plus 3 sine squared theta minus 1 is equal to 0. This is a hidden quadratic, so we can solve our hidden quadratic using factorization. So that's 4 sine squared theta, and then we've got a 1 here. This should be sine squared theta, and then a 1 is equal to 0. We want to get a positive 3 sine squared theta. So that's 4 sine squared theta minus sine squared theta. If you multiply negative 1 and 1, you get negative 1. Okay. So this becomes 4 sine squared theta minus 1 is equal to 0. And we've got sine squared theta plus 1 is equal to 0. Let's start with the first equation. That's 4 sine squared theta is equal to 1. So sine squared theta is equal to 1 over 4. Take the square root of both sides. Sine theta is equal to plus or minus the square root of 1 over 4. So you've got sine theta is equal to the square root of 1 over 4 is 1 over 2. So that's sine theta is equal to, sine theta is equal to half, and sine theta is equal to negative 1 over 2. And now theta is equal to arcsine of 1 over 2. So theta is equal to, let's punch that into our calculator, arcsine of 1 over 2. Make sure you're in degrees. That gives us 30 degrees. Okay, so to find the other solutions within the given interval, we can use 30 degrees as our principal value, and we'll use the formula PV times minus 1 to the power n plus 180 n. So n is an integer. And in this case, let's substitute n with 1. So that becomes 30, which is our principal value, times negative 1 to the power 1 plus 180 times 1. And this would give us 150. And so that's our other solution within the given interval, 150 degrees. And now let's evaluate sine theta is equal to negative half. Theta is equal to arcsine of negative 1 over 2. So theta is equal to negative 30 degrees. Again, we use the same formula to get solutions within the given interval. So in this case, our PV is now negative 30. Negative 30 times negative 1. Let's substitute n with 1. That's plus 180 times 1. And this gives us 180 plus 30, which is equal to 210 degrees. And now let's check if there are any other solutions within the given interval. So we'll substitute n with 2 in this case, so negative 30, negative 1 to the power 2 plus 180 times 2. And this gives us 360 minus 30, which is 330 degrees. 330 degrees, that's also within the given interval. If we keep going, that the solutions will be outside of our interval. Now we still haven't evaluated this equation, so that would become sine squared theta is equal to negative 1. Take the square root of both sides. We've got sine theta is equal to the square root of negative 1. And so that means theta has no solution, since we cannot find, or rather we cannot get real values for the square root of a negative number. And so we can conclude that therefore theta is equal to, pick only the solutions that are within the given interval. So we've got 30 degrees, and then we have 150 degrees, and then we've got 210 degrees, and then finally we've got 330 degrees. And this would be our final answer. Number 7, the equation of a curve is x cubed plus y squared plus 3x squared plus 3y is equal to 4. Part A, show that dy dx is equal to negative 3x squared plus 6x over 2y plus 3. So we have an implicit function, so we will perform implicit differentiation. So that's x cubed plus y squared plus 3x squared plus 3y, and this is equal to 4. And so if you differentiate x cubed, you get 3x squared. If you differentiate y squared, you get 2y dy dx. And then if you differentiate 3x squared, you get 6x. If you differentiate 3y, you get 3 dy dx. And this is equal to, if you differentiate a constant, you get 0. Okay, so let's put the terms with dy dx on one side. So 2y dy dx plus dy dx is equal to, let's move the other terms to the right hand side. So that becomes negative 3x squared and negative 6x. This should be 3 dy dx from here. So this becomes, if we factor out dy dx, this becomes 2y plus 3 is equal to negative 3x squared minus 6x, and divide both sides by 2y plus 3. dy dx is equal to negative 3x squared negative 6x, and this is O over 2y plus 3. And now notice how they have a negative sign in line with the fraction line. And to achieve that, we can factor out a negative sign in our numerator and bring that negative sign down to the fraction line. So that would be negative. And then our numerator now becomes 3x squared plus 6x, since we factored out a negative sign, and this is over 2y plus 3, and this would be the final answer. Part B, hence find the coordinates of the points on the curve at which the tangent is parallel to the x-axis. So if the tangent is parallel to the x-axis, this is our x and this is y. So if our tangent is parallel to the x, it looks something like this. And what this means is that we don't have any change in the y direction. So it means that dy from dy dx, it means that dy is equal to 0. So we can say that dy is equal to 0. We've evaluated dy dx in part 1, and we know that dy dx is equal to negative 3x squared plus 6x over 2y plus 3. So we can equate the dy part to the top part of our fraction on the right hand side. So it means that dy is equal to 0, so 3x squared plus 6x is equal to 0. 3x squared plus 6x is equal to 0. So since we want the coordinates of the points on the curve at which the tangent is parallel to the x-axis, we're also going to need the equation of the curve, which is given in the stem of the question. That is x cubed plus y squared plus 3x squared. Let's copy that down. X cubed plus y squared plus 3x squared, and then plus 3y equals 4, plus 3y is equal to 4. So now we can solve the two equations simultaneously. Let's make x the subject of the formula in our first equation. So we can do that by factoring out 3x. So that becomes x plus 2. So that becomes 3x is equal to 0, and then x plus 2 is equal to 0. So we get x is equal to 0 and x is equal to negative 2. So now we're going to substitute these values of x into our equation of the curve. So we'll start at x is equal to 0. Substitute x with 0, you get 0 cubed plus y squared plus 3 times 0 squared plus 3y is equal to 4. So this becomes y squared plus 3y. Bring the 4 to the left hand side, minus 4 is equal to 0. Let's factorize. This is y plus 4 and y minus 1 is equal to 0. So you get y is equal to -4 and you get y is equal to 1. So we know that at x is 0, we have the coordinates 0, -4 and 0, 1. And now let's evaluate at x is equal to -2. At x is equal to -2. So if we substitute, this is -2 cubed plus y squared plus 3 times -2 squared plus 3y is equal to 4. So that becomes -8 plus y squared. And this is plus 4 times 3, which is 12, plus 3y. Let's bring the 4 to the left-hand side, so that's -4 is equal to 0. And if we group like terms, we end up with y squared plus 3y. And then we've got -4 plus 12, which is +4, minus 4, so that will all cancel out. And this is equal to 0. Let's factorize. You've got y times y plus 3 is equal to 0. So you get y is equal to 0 and y is equal to -3. So at x is equal to -2, we get the coordinates -2, 0 and -2, -3. And therefore our final answer will be this set of coordinates 0, -4, 0, 1, and these sets of coordinates -2, 0 and -2, -3, and that's the final answer. Number 8. The variables x and y satisfy the differential equation e to the power 4x dy dx is equal to cos squared 3y. It is given that y is equal to 0 when x is equal to 2. Solve the differential equation, obtaining an expression for y in terms of x. Okay, so let's start by separating our variables. So we end up with 1 over cos squared 3y with respect to y is equal to, this would be 1 over e to the 4x with respect to x. Okay, and we can write this as 1 over cos squared, we know that's sec squared. So sec squared 3y with respect to y. And let's bring e to the 4x to our numerator. So that's e to the -4x with respect to x. And now let's integrate both sides. If you integrate sec squared, you end up with tan. So this becomes 1 over 3 because of this 3 over here. Tan 3y plus a constant of integration, and then that becomes -1 over 4 e to the -4x, and we're given that y equals 0 when x is equal to 2. So this becomes 1 over 3 tan 3 times 0 plus our constant here, that's -1 over 4 e to the -4 times 2. So tan 0 is 0, so c is equal to -1 over 4 e to the -8. And we can substitute that into our equation. So what we have is 1 over 3 tan 3y minus 1 over 4 e to the -8, which is equal to -1 over 4 e to the -4x. And we want an expression for y in terms of x, so it means we have to make y the subject of the formula. So this becomes 1/3 tan 3y is equal to a quarter e to the -8, we've moved this to the right hand side, minus 1 over 4 e to the -4x. And now let's multiply through by 3 to get rid of this 3. So it becomes tan 3y is equal to 3 over 4 e to the negative 8 minus 3 over 4 e to the negative 4x. And now we're going to arctan both sides. So 3y is equal to arctan of 3 over 4 e to the negative 8 minus 3 over 4 e to the negative 4x. And then divide both sides by 3. So y is equal to 1/3 arctan of 3 over 4 e to the negative 8 minus 3 over 4 e to the negative 4x. And this would be our final answer. Number 9, let f of x equal 17x squared minus 7x plus 16 over 2 plus 3x squared times 2 minus x. Part A, express f of x in partial fractions. So we've got a quadratic vector and a linear vector. So we can state that 17x squared minus 7x plus 16 over 2 plus 3x squared times 2 minus x is equal to ax plus b for quadratic vector over 2 plus 3x squared plus c for a linear vector over 2 minus x. And now we're going to multiply through by this denominator to get rid of all the denominators. So it becomes 17x squared minus 7x plus 16 is equal to ax plus b, and this will be multiplied by 2 minus x plus c, which is multiplied by 2 plus 3x squared. Okay, so now to evaluate c, we can substitute x with 2. So that becomes 17 times 2 squared minus 7 times 2 plus 16. X equals 2 gets rid of this bracket, which eliminates this whole thing. So that's c 2 plus 3 times 2 squared. And so let's punch the left hand side into a calculator. 17 times 2 squared minus 7 times 2 plus 16, that gives us 70, and that's equal to 2 plus 3 times 2 squared. So that's 3 times 4, which is 12, plus 2, which is 14. So you've got 14c. Divide both sides by 14. So 70 over 14 gives us 5. And now let's evaluate it. X is equal to 0 to allow us to evaluate b. So this becomes 17 times 0 squared minus 7 times 0 plus 16 is equal to ax plus b. So that's a times 0 plus b times 2 minus 0 plus c, which we evaluated to be 5, times 2 plus 3 times 0 squared. Okay, and so the left hand side is 16 is equal to, that's b times 2, so 2b, and then we've got 5 times 2, which is 10. So this becomes 2b is equal to 16 minus 10, which is 6. Divide both sides by 2, b is equal to 3. And now let's evaluate at x equals 1 to get a. So at x is equal to 1, that's 17 times 1 squared minus 7 times 1 plus 16 is equal to a times 1 plus b, which we evaluated to be 3. So that's 2 minus 1 plus c, which we evaluated to be 5. 2 plus 3 times 1 squared. So if we simplify our left hand side, that's 17 minus 7 plus 16, which gives us 26, and that's equal to a plus 3 plus the last bracket will give us 2 plus 3, which is 5. 5 times 5, 25. So 26 is equal to a plus 28. So a is equal to 26 minus 28, which is negative 2. And so this means that our final answer would be that, therefore, f of x is equal to negative 2x plus 3 over our quadratic, which is 2 plus 3x squared, plus c, which we evaluated to be 5, over our linear vector, which was 2 minus x. And this would be our f of x and partial fraction. Now let's move on to part B. Hence obtain the expansion of f of x in ascending powers of x up to and including the term in x cubed. Okay, so let's just copy down f of x first. F of x is equal to negative 2x plus 3 over 2 plus 3x squared plus 5 over 2 minus x. So let's start with the first term. If we bring the denominator up to the numerator, it becomes negative 2x plus 3 times 2 plus 3x squared to the power negative 1. So let's start by expanding this part first using the formula for binomial expansion. And so that's 2 plus 3x squared to the negative 1. To be able to use our formula, we need this part to be a 1. So that means we have to factor out the 2. So if we factor out 2, that becomes 1 plus 3 over 2x squared. This is all to the power negative 1. Distribute the power negative 1. So that's 2 to the negative 1 times 1 plus 3 over 2x squared to the negative 1. So this is 1 over 2 times 1 plus 3 over 2x squared to the negative 1. And now let's use the formula for binomial expansion. So this becomes half times 1 plus n, which is negative 1, times x, which is 3 over 2x squared. Now, if we're to continue expanding, the next term that we would get is in x to the power 4, but we're told to only go up to x cubed, so we will stop here. So this will simplify to give half times 1 minus 3 over 2x squared, and that's half minus 3 over 4x squared. So we can now come back to this part, and we're going to replace this with what we have expanded using the binomial expansion formula. So this would become, let's scroll down, that would become negative 2x plus 3 times 1 over 2 minus 3 over 4x squared. And now let's expand. So we'll start with negative 2x times half. And now let's expand our brackets. We'll start with negative 2x times half. That will give us negative x. Then negative 2x times negative 3/4 x squared. That will give us a positive 3 over 2x cubed. And then we go on to 3 times half, which gives us 3 over 2. And then finally we have 3 times negative 3 over 4x squared, which is negative 9 over 4x squared. And if we just write this in order of ascending powers of x, that's 3 over 2 minus x minus 9 over 4x squared plus 3 over 2x cubed. So this would be the expansion of our first term of f of x, which is this term over here. Now let's expand our second term, 5 over 2 minus x. So if we bring the 2 minus x to the numerator, that becomes 2 minus x to the power negative 1. And again, this 2 must be a 1, so we have to factor it out. So that's 2, 1 minus x over 2. This is o to the power negative 1. Distribute the power negative 1, so that's 5 times 2 to the negative 1 times 1 minus x over 2 to the negative 1. And this would become 2 to the negative 1 is 1 over 2, and if you multiply that by 5, that's 5 over 2 times 1 minus x over 2 to the power negative 1. We've run out of space here, so I'll just work that out on the side. So this is 5 over 2, 1 minus x over 2 to the power negative 1. Let's use the formula for binomial expansion. So that's 1 plus n x, which is negative x over 2, plus we do negative 1 plus n minus 1 over 2 factorial times x squared plus n minus 1 n minus 2 over 3 factorial times x cubed. Then we close our bracket. So this would be 5 over 2, 1. If we simplify this, that's x over 2, x over 2. Okay, let's evaluate the term in x squared. That's negative 1, negative 1, negative 1 over 2 factorial times negative 1 over 2 squared. And so that's a quarter x squared plus 1 over 4x squared. And then the term in x cubed, so that's negative 1, negative 1, negative 1 times negative 1, negative 2 over 3 factorial times negative 1 over 2 to the power 3, and that gives us 1 over 8 x cubed. And let's multiply through by 5 over 2, so that's 5 over 2 plus 5 over 4x plus 5 over 8x squared plus 5 over 16x cubed. Now let's combine these two expansions. Since they make up f of x, we'll just write it at the top here since we've run out of space. So we've got 3 over 2 plus 5 over 2 minus x plus 5 over 4x minus 9 over 4x squared plus 5 over 8x squared plus 3 over 2x cubed plus 5 over 16x cubed. 3 over 2 plus 5 over 2 gives us 4. And then minus x plus 5 over 4x, that's plus 1 over 4x. And then we've got minus 9 over 4x squared plus 5 over 8x squared. And that gives us negative 13 over 8x squared. And then we have 3 over 2 plus 5 over 16 for our term in x cubed, and that's 29 over 16 x cubed. And this is our final solution. Let's move on to part C. State the set of values of C for which the expansion in B is valid. Give your answer in an exact form. Okay, we know that the conditions that allow us to use the formula for binomial expansion are that the modulus of x should be less than 1. So let's identify all the values of x that we used in part B. So we've got negative x over 2. So negative x over 2 should be between negative 1 and 1, or in other words, the modulus of negative x over 2 should be less than 1. And then we also used 3 over 2x squared. Okay, and that should also be between negative 1 and 1. In other words, its modulus should be less than 1. And now let's take negative half outside of the modulus function less than 1, and then multiply both sides by negative 2. So that's less than negative 2. We can just write this as mod x is less than 2. Since the modulus always gives us positive values, we can bring out the 3 over 2 outside the modulus. So that's mod x squared is less than 1. And so mod x squared is less than, that will become 2 over 3. Then if we were to take the square root on both sides, we've got mod x is less than the square root of 2 over 3. Now we need to check which one of these two inequalities satisfies both regions. So if I'm to draw a number line here, mod x is less than 2 means that x is between negative 2 and 2. So if we were to draw a number line here, we'd have, say, negative 2 is here and our 0 would be there, so 2 should be somewhere there. Now let me change color to blue. Root 2 over 3, if you punch that into your calculator, root 2 over 3 gives you approximately 0.8. So we're saying 0.8 would be somewhere here. This is negative 0.8, and that would be 0.8. So that means our blue line would be running from here to here. So we want the region that consists of both the blue region and the red region. And so that's this region from negative 0.8 to 0.8. So that will be our solution. So our final answer would be that the modulus of x is less than the square root of 2 over 3. And that is our final answer. Number 10. The diagram shows the curve y equals x cos 2x for x is greater than or equal to 0. Part A. Find the equation of the tangent to the curve at the point where x is equal to 1 over 2 pi. Okay, since we want the equation of the tangent to the curve, it means we're going to have to find dy dx first. Dy dx is equal to, we're going to use the product rule. So hold x and then differentiate cos 2x, which gives us negative 2 sine 2x plus hold cos 2x and then differentiate x, that gives you 1. So if we simplify this, that's dy dx is equal to negative 2x sine 2x plus cos 2x. Okay, and now we're told that we want the equation of the tangent to the curve when x is equal to 1 over 2 pi. So to get the gradient of the tangent, let's substitute x is equal to half pi into our gradient function. So that's negative 2 times 1 over 2 pi sine 2 times 1 over 2 pi plus cos 2 times 1 over 2 pi. So if you punch that into your calculator, that's negative 2 times 1 over 2 pi times sine of 2 times half pi. So that's just sine pi, which gives you, make sure you're in radians, and you get 0. And then let's evaluate cos pi. Cos pi, that's negative 1. So you end up with negative 1 as the gradient for our tangent. So m is equal to negative 1. And now we need to get the coordinates of the tangent at x is equals to 1 over 2 pi. So let's substitute that into our equation. So that becomes y is equal to 1 over 2 pi times cos of 2 times 1 over 2 pi. So this simplifies to give negative 1 over 2 pi. So our coordinates are 1 over 2 pi and negative 1 over 2 pi. Now that we have the gradient of the tangent and a set of coordinates, we can now find the equation of the tangent using y equals mx plus c. So y is negative 1 over 2 pi. Our gradient is negative 1 and x is 1 over 2 pi plus c. So that's negative half pi is equal to negative half pi plus c. So if you take negative half pi to the other side, it will cancel out and c is equal to 0. Therefore, the equation of our tangent is y is equal to negative x. And that's our final answer. Part B. Find the exact area of the shaded region shown in the diagram bounded by the curve and the x-axis. Okay. So we need to find the point where the curve intersects the x-axis. So our curve is y is equal to x cos 2x. So let's equate that to 0. So we've got x is equal to 0 and we've got cos 2x is equal to 0. So when x is 0, that's the origin. Okay, there was a mistake on our limits. Cos 2x is equal to 0, so 2x is equal to arc cos of 0, and arc cos of 0 is equal to 1 over 2 pi, so 2x is equal to 1 over 2 pi. Then divide both sides by 2 to get x as the subject of the formula, which gives us a quarter pi. And now we can find the area of the shaded region with our limits 0 and pi. So we are integrating x cos 2x from 0 to pi with respect to x. As you can see, we have a product, so we'll use integration by parts. Let u equal x and dv dx equal cos 2x. So if you differentiate x, you get du dx to be 1. And if you integrate cos 2x, you get 1 over 2 sine 2x. And now use the formula for integration by parts. So the integral of x cos 2x with respect to x is equal to uv, which is half x sine 2x, minus the integral of v dv dx. Let's move the half outside the integral sign. So that's sine 2x with respect to x. Okay, so that means we have to integrate sine 2x. So the integral of sine 2x with respect to x is equal to negative 1 over 2 cos 2x. So let's substitute that. That becomes the integral of x cos 2x with respect to x is equal to 1 over 2x sine 2x minus half times negative 1 over 2 cos 2x. Let's expand, so that's half x sine 2x plus a quarter cos 2x. This is our integral of x cos 2x with respect to x. And now if we go back to the stage, we can substitute our limits. So our upper limit is 1 over 4 pi. And so that's sine 2 times a quarter pi plus 1 over 4 cos 2 times a quarter pi. Let's put brackets over here. Minus, let's substitute in our lower limit, that's half times 0 sine 2 times 0 plus 1 over 4 cos 2 times 0. And let's close our brackets. Let's evaluate our upper limit, that's 1 over 2 times 1 over 4 pi times sine 2 over 4 pi, and that gives us 1 over 8 pi, and then we've got 1 over 4 cos 2 over 4 pi, which gives us a 0. Now let's evaluate our lower limit. The first term will give us a 0 since we're multiplying by 0 here. And then we've got 1 over 4 cos 0, which will give us a quarter. So this means that our final answer is 1 over 8 pi minus 1 over 4. This represents the area of the shaded region. Let's move on to number 11. The line L has equation R is equal to I minus 2j minus 3k plus lambda times negative I plus j plus 2k. The points A and B have position vectors negative 2i plus 2j minus k and 3i minus j plus k respectively. Part A. Find a unit vector in the direction of L. Okay, so our direction vector for L is negative I plus j plus 2k. To get its unit vector, we have to divide the direction vector by its magnitude. So let's start by finding its magnitude, which is negative 1 squared plus 1 squared plus 2 squared, and that gives us. So that means our unit vector for the direction of L is 1 over root 6 times negative I plus j plus 2k, and that's our final answer. The line M passes through the points A and B. Find a vector equation for M. Okay, so to get our vector equation, we first need to find the direction vector A, B. And we can find that by saying OB minus OA. And we are given that OB is 3i minus j plus k. So AB is equal to 3i minus j plus k minus OA. OA is negative 2i plus 2j minus k. Negative 2i plus 2j minus k. Let's expand our bracket. So AB is equal to 3i minus j plus k plus 2i minus 2j plus k. Simplify like terms. AB is equal to 3i plus 2i, that's 5i, negative j, negative 2j, that's negative 3j, k plus k, that's 2k. So the direction vector of AB is 5i minus 3j plus 2k. And now let's write our vector equation for M. So that's R is equal to, and we'll use the point A. So that's negative 2i plus 2j minus k plus, we use mu, times 5i minus 3j plus 2k, which is our direction vector. And this is our vector equation for M. Part C, determine whether lines L and M are parallel, intersect, or askew. Okay, so let's just copy down their equations first. So L is R is equal to I minus 2j minus 3k, I minus 2j minus 3k plus lambda times negative I plus j plus 2k, negative I plus j plus 2k. And then L is R is equal to 2i plus 2 negative 2i plus 2j minus k plus mu times 5i minus 3j plus 2k. Right, if these vector equations are parallel to each other, then their directions should be scalar products. So for example, if we take negative I plus j plus 2k, right, that's our direction for L, and then 5I minus 3j plus 2k, that's our direction for M. So if we were to multiply, in this case we have a 5I, if we were to multiply the first direction vector, we'd end up with negative 5I plus 5j plus 10k. You can see that this does not give us the direction vector for M. So that means that these two lines are not parallel. And now we have to determine whether they intersect or they are skew. So we can form three equations. Let's write our equations as column vectors first. So R is equal to, that's 1 minus 2 minus 3 plus lambda, that's negative 1, 1, 2. And then for M, R is equal to, that's negative 2, 2, negative 1 plus mu 5, negative 3, 2. So we can form three sets of equations. The first one here being 1 plus lambda times negative 1. So that's 1 minus lambda is equal to negative 2 plus 5 mu. And then we've got negative 2 plus lambda is equal to 2 minus 3 mu. And then we have negative 3 plus 2 lambda is equal to negative 1 plus 2 mu. Okay, let's deal with the first equation. 1 minus lambda is equal to negative 2 plus 5 mu. Let's make lambda the subject of the formula. So lambda is equal to 1 plus 2 minus 5 mu. Lambda is equal to 3 minus 5 mu. Let's substitute this into our second equation. So negative 2 plus lambda, which is 3 minus 5 mu, is equal to 2 minus 3 mu. So that's negative 2 plus 3, which gives us 1 minus 5 mu is equal to 2 minus 3 mu. Let's make mu the subject of the formula. So you end up with 5 mu minus 3 mu is equal to 1 minus 2. So 2 mu is equal to negative 1. Therefore, mu is equal to negative 1 over 2. Okay, now let's use this equation to evaluate lambda. Lambda is equal to 3 minus 5 mu, and mu is negative 1 over 2. So lambda is equal to, let's punch that into our calculator, 3 minus 5 times negative 1 over 2, and that gives us 11 over 2. Now to check if the lines are intersect, we can substitute our values for mu and lambda into our third equation. And if the third equation is satisfied, then we know that our lines are intersect. So our third equation is negative 3 plus 2 lambda. Lambda is 11 over 2. And then we have negative 1 plus 2 times mu. Mu is negative 1 over 2. If we simplify this, that's negative 3 plus 2 times 11 over 2. So the left-hand side is 8. And then our right-hand side is negative 1 plus 2 times negative 1 over 2. And that gives us negative 2. We can tell that our third equation is not satisfied. Therefore, this means that our lines are not intersect. And since we already proved that our lines are not parallel, it means that our lines must be skew. So we can conclude that therefore our lines L and M are skew. And that's our final answer. So that's the final question in this paper. If you enjoyed this breakdown, please like and subscribe for more videos like this. Comment down below which paper would you like me to break down next. Bye bye.